Nos va a hablar Emilio Pérez Belda, que es arquitecto, director de la Fundación Emilio Pérez Piñero, y la presentación es de las estructuras de Emilio Pérez Piñero, evolución y tipos. Como quieras.
Good afternoon, ladies and gentlemen, dear friends. I would like to thank you all very much to be here in this special occasion. I would also like to read a brief posthumous homage to the memory of Professor Felix Skrieg, who sadly passed away on Friday, the 30th of August. To the very last moment, despite his illness and serious health problems, Professor Skrieg worked on the organization of this Congress. He was a pioneer in modular and transformable structures. He was also one of the major, if not the major, contributor to the divulgation of the works of my father, Emilio Pérez Piñero. He was a great master and also a good friend. I am therefore especially touched for his loss. His passion and perseverance made this Congress come true. He wanted this Congress, for which he had cherished great hopes, to be in honor of Emilio Pérez Piñero. I would like Transformables 2013 to be in honor of Felix Skrieg too. I will mention also Professors José Sánchez and María Teresa Rodríguez, who have been decisive for the success of this Congress. I also want to thank the University of Sevilla and its School of Architecture for their hospitality. Well, now let me introduce a little from myself. My name is Emilio Pérez Piñero, Pérez Belda, excuse me, Managing Director of the Emilio Pérez Piñero Foundation. As many of you know, I am Emilio Pérez Piñero's eldest son. I have been living together with my father's works from the early stage of my life. To present this conference, I could have brought recent color photographs, but I preferred to bring photos taken in those days, many of them made by Pérez Piñero himself. As we can see in the timeline, we're talking about the works of Emilio Pérez Piñero. We must have in mind that the architect only worked for 10 years. He died when he was only 36 years old. His designs were brilliant and visionary, and his solutions were always innovative and effective. His promising career was sadly cut by a tragic car accident. Nobody knows what he could have accomplished if his life had been longer, but his legacy lives on, as evidenced by the organization of this International Congress. During the next minutes, I will try to make you know about some particular aspects of Pérez Piñero's works. First, it is needless to say that Pérez Piñero's working methods were quite original compared to those of other contemporary authors. He always worked alone. His team was formed by a small group of local artisans previously trained by him to work with the necessary precision. Pérez Piñero did not confine himself to merely utopian designs on paper, preferring to develop them by means of applied solutions. He always built test models made out of the same materials which would be used later in real structures. We know that he had very little information about the contemporary structures, which were at that time being developed in Europe, America, and Japan. Despite his relative isolation, Pérez Piñero has influenced many renowned architects, such as the Archigram Group or Norman Foster, since his works were largely developed by the specialized publication of the time. Throughout his short career, Pérez Piñero's structures evolved in a logical and rational way. As he used to say, "I just don't stop. I work in a hurry." His personal work-in-progress philosophy would make him cut short a whole system of structures to embrace a new idea, thought in the middle of a process. Often, his own models became obsolete before they were finished. Pérez Piñero worked mainly with two types of structures. Modular structures. In this slide, we can see a module being installed in the structure. We have the module, and here is the structure being constructive. And deployable structures. In this slide, we can see the first deployable structure made by Pérez Piñero. In my opinion, the best method to analyze and understand Pérez Piñero's works is to consider the basic components of his structures, namely the nodes and the rods. Now let's talk about the nodes. In Pérez Piñero modular structures, we can consider two types of 6 millimeters thick nodes. The closed node on the left of the slide. On the left of the slide, we can see the closed node and the open node. The open node is on the right of the slide. I don't know if you can see the letters because the seat is too much height. In the two cases of the nodes, they are connecting different modules in a modular structure. With them, we can cover spans of more than 30 meters, with only 6 millimeters thick. On the other hand, when we speak about deployable structures, Pérez Piñero used basically two types of nodes. First, the 3-rod node is composed of a core. You can see here the core, with 3 studs lying within the same plane, forming angles of 120 degrees between each. In this node, the 3 bars meet and articulate, as you can see on the right of the slide. Secondly, in the 4-rod node, 4 rods meet and articulate. This node is composed of a core with 4 studs laying within the same plane, forming, in this case, 90-degree angles between each. And now, let me talk about the rods. When we speak of the rods, it is important to note that in the case of modular structures, Pérez Piñero worked mainly with the polyhedral decomposition of the sphere, based on the spherical icosahedron as Fuller did. However, Pérez Piñero greatly simplified the dome assembly, grouping the rods together in pentagonal and hexagonal parts. Unlike Fuller, this system allowed him not only to build permanent simpler covers, but also to build mobile domes easily and quickly assembled, dismantled, and transported. In this slide, we can see Pérez Piñero helping to his group of artisans. Here is Pérez Piñero. As in nodes, when we speak of deployable structures, there are 2 types of rods. The 3-node rod. In the slide, you can see the 2 types of 3-node rod. On the left, we have the 3-node rod with 3 nodes of 3 studs. We can see 3 nodes of 3 studs. And on the right of the slide, we can see the 3-node rod with 3 nodes of 4 studs. 3 nodes of 4, 1, 2, 3, 4 studs. When using 3-node rods, if the central node is at the middle of the rod, that is to say, at the same distance from the end nodes, flat spatial structures are obtained. You can see now the slides. If the central node is not at the same distance, being the distance from an end node, be distance longer than the distance to the other end node, a distance, we obtain a curved spatial structure. The curvature is proportional to the difference in length between the 2 half bars. If we combine the above 2 types of nodes with these 2 types of bars and play with the lengths of the half rods, we get a very complex variety of types. Unfortunately, we have no time to describe them all. In the slide, you can see some possible combinations. Let's now have a look at some examples of the structures designed by Pérez Piñero, where we can see their evolution at time. In 1961, Pérez Piñero won the International Union of Architects London Congress award with his traveling theatre. As shown in the sequence of photographs, the folded structure is transported on a track as a compact package. When the track is placed in the target area, the structure is deployed by means of a telescopic tower. The theatre is then ready to use. Since the fabric roof needed to cover it is included in the pack, folding and unfolding together with it. In September 1961, Pérez Piñero improved the design of the structure, including the necessary stiffening elements in the deployable compact package. They consisted of two groups of wires placed on the outer and the inner faces of the dome. The wires will or will not work depending on the sign of the bending moment happening at each section of the dome. The scale model you can see in the slide was produced in considerable dimensions so that the structure's behavior could be properly studied and later applied to a life-size case. This model was also used 3 years later for the testing the deployment of a transportable dome from a helicopter. The compact package of rods, flies hanging down a helicopter, attached by 5 nodes placed on the grid's inner face. When the structure arrives at its location, final location, the fastening belt, which prevents the folded rods for deploying, is released while the helicopter lifts the structure up in the air. The structure can therefore be automatically deployed and stiffened in the right place. When the time comes to move it somewhere else, the structure is hung from 5 nodes belonging to the external face of the dome, and the helicopter has just to pull up again to automatically fold the grid, which is now ready to be airborne to a new location. In January 1964, Pérez Piñero built the transportable pavilion for exhibitions 25 Years of Peace. As we can see in this slide, in this case, the architect decided to build a new flat deployable structure totally made of aluminum. For this purpose, he designed the previously seen 4-rod node. A hybrid system, including compressed parts on the outer face of the truss and wires on its inner face, was used in order to stiffen the whole structure. Prefabricated molded aluminum plates were used to cover it. The pavilion had a total surface of 8,000 square meters, divided into 12 by 9 meters flat and folded modules. It was designed, manufactured, assembled in only 3 months. 2 years later, the architect made a new traveling theater for festivals of Spain. To fulfill his mission, Pérez Piñero designed his first modular structure, consisting of a set of 2 nearly semi-spherical intersecting domes twinned by a common vertical plane. In the slide, we can see this common vertical plane. Here. And now let me tell you a little anecdote. When dealing with the transport of the theater, Pérez Piñero realized that he needed more tracks to move the audience seats than to move the structure itself. He therefore designed a row of 12 folding seats which occupied the same space of a single regular seat. In 1967, the architect designed and manufactured another travel room, which could be used to project films by means of the Cinerama system. This structure consisted of a single semi-spherical dome, bigger than his previous domes, which all had 31 meters of diameter. He only improved the auxiliary assembling crane, which remained fixed at the center of the dome, here in the center of the dome, placing the parts in an upward movement around the dome till reaching the top. Two years later, the architect was commissioned to design and build the cover of the early Christian necropolis of Tarragona. Here, Pérez Piñero's main concern was to protect the excavation from bad weather conditions, as well as finishing the job in the easiest and cheapest way. To do so, he designed a series of sailbolts whose triangulation was based on the spherical icosaedron. These were modular structures of a geodesic kind, but at this time they were designed to stay on the site. In this project, Pérez Piñero used a very long radius sphere as a directrix. This way, he could provide a remarkable spatial continuity to the volume created under the domes. Rigid fiber cement pads of an existing in the market model were used as the covering element in order to reduce the final price of the whole. A less than 5 kilograms per square meter weight was obtained in this structure. All in all, 26 bolts of 180 square meters each were built, covering a total area of 4,680 square meters. During these hectic years, in which the architect developed many new projects, he kept on improving the old types of deployable structures designed to date. As a consequence, he came up with a new challenge: to find a solution to the hypothetical case in which a very big dome could not be handled and transported in a single package. This new challenge will result in the deployable reticulated dome for large spans. The whole structure was prefabricated in 7 modules. You can see the 7 modules, which had to be deployed and stiffened on the ground, and then lifted up and locked together in order to close the dome. Excuse me. At the beginning of 1969, he received a letter from the U.S. Navy. In the letter, the Navy expressed its interest in his patents in order to design a fast assembly pavilion, which should be later set up in Antarctica. Pérez Piñero's response to this new challenge was the design of an automatically unfolding tent built on a hexagonal base. Aided by a metal spring, the tent would unfold automatically, making the task of the assemblers easier. As usual, the fabric cover folded together with the structure, which in this particular case should also be able to bear extreme weather conditions. It was an X-shaped system which will be the most used by later authors. The tent could easily reach significant dimensions with a completely unobstructed interior, which had the form of a hexagonal base prism and was around 4 meters height. The covering structure was very simple, topped by the vertical element which hosted the opening spring. You can see here, we can see the spring on the top of the structure. In November of that year, NASA contacted Pérez Piñero, asking him to assist the possibility of setting up a greenhouse on the moon in order to create an artificial atmosphere inside. In this slide, you can see the photograph of the moon which sent NASA to Pérez Piñero through Candela. As a result of this demand, Pérez Piñero designed the new type of folding spherical structure based on his folding reticular dome for large spans. However, some improvements were added to the external face of the structure, which was thicker and opened automatically by means of a system of springs, not needing any human intervention. In the slide, you can see the springs which allow the automatically opened. The structure was to be transported in the nose of the lunar module. Once the landing on the moon had taken place, the dome would automatically open, installing the greenhouse on the surface. Obviously, the plastic cover folded together with the prefabricated structure. In this slide, we can see the dream of Pérez Piñero could have been. That year, Pérez Piñero was called by artist Salvador Dalí, who commissioned him to design and build a geodesic dome for his Figueras museum. According to Dalí's wishes, the architect started to design a stationary geodesic yet totally prefabricated dome. Pérez Piñero decided to design a dome composed of 2 parallel layers connected to each other by small radial metal parts, which would give a sense of unity to the whole structure. For the inner layer, he used an inverted T-shaped rod section in order to properly accommodate to the covering glasses. The external layer, built in a lower frequency, was mainly used to facilitate the cleaning and the maintenance of the inner layer. Despite the small dimensions of the dome, whose sphere diameter was about 14 meters long, Pérez Piñero provided the project with some technical innovation, namely with the pendants in it built on. These elements were solved by means of a slightly tilted geodesic dome segment, later covered with reinforced concrete. In the slide, you can see these pendants. These are the pendants. These elements transform the irregular ground plan into a circular ring on which the glass dome will later rest. This is the ring. Another consequence of the professional relationship between Salvador Dalí and Emilio Pérez Piñero was a new type of deployable structure called system of articulated planes covering a reticular deployable space frame. Originally, Dalí's purpose was to close the gap between the museum's courtyard and the dome-carved area. To achieve this task, Pérez Piñero turned to one of his old ideas, as have said Professora Perez before, when he worked on the designs of deployable antennas for artificial satellites. The design consisted of a series of 1 square meter glasses attached to one of his flat deployable structure, so that all the glasses would integrally fold or unfold at the time the structure opened or closed. The operation may look simple, but it is actually a very smart way to package a plane. The project was never accomplished due to the architect's early death. However, a scale model he gave to Dalí as a present is still exhibited in a chapel room at the Dalí Museum in Figueras. In 1992, we built a scale model to be exhibited in motion in the Murcia Pavilion at the World Expo 92 here in Sevilla. In 1971, Pérez Piñero had the opportunity to design a new structure for large spans, not deployable this time, where he used patterns he hadn't used before. On the occasion of the San Sebastián City Council's call for tenders for the covering of the Anoeta Velodrome, the architect designed a parabolic directrix dome with 130 meters of diameter, built by means of rectangular section metal bars, which described an hexagonal truss covered by warped lozenges which allowed to control the lighting and the ventilation of the room. Finally, in 1971, Pérez Piñero was commissioned to study the possible covering of the Campo Pequeño bullring in Lisbon, Portugal. As he used to do, instead of solving the structural problems bringing back one of his old solutions, he came up with a brand new design which had nothing to do with what he had done before. The reticular dome is an spherical directrix structure which moves like a camera diaphragm. Despite the apparent simplicity of the system, when studying it in depth, we are surprised by the complexity of its motion geometry. Pérez Piñero couldn't finish the job, but he left an almost completed scale model, which is now on display at the Emilio Pérez Piñero Foundation in Calasparra, along with the rest of the author works. Well, we have now arrived at the end of my presentation. I hope that I was able to provide you with a wider understanding of Pérez Piñero's works. And now I don't know if we have still some time for questions. Anyway, do not hesitate to contact me here during the Congress. We are eager for developing new contacts with other institutions all over the world. Thank you very much for your attention.